Hi all, here begins the 5th video in our BNB Chain development tutorial series. In the following 2 videos, course 5 and course 6, we will be seeing several smart contract examples. So they will be full smart contracts that can be compiled, deployed, and connect to the front end directly. And they all reach one expected aim and goal, respectively. And we hope that through seeing these examples, we can better demonstrate and help you understand the features, syntax, and semantics of the Solidity programming language that we talked about in the previous videos. So in course 5, we will be seeing 3 contracts: a coin token, then crowdfunding, and finally delegated voting. First, the coin token. The idea of the coin token is basically you can spread out a coin or a type of assets of your choice. It will be able to allow people to send, receive these toys, and then you will also be able to mint coins to a certain person. So the coin token is a rather simple contract, and the full contract is displayed in this slide. We will go over these line by line. So first, we use contract coin to declare a contract called coin. But before that, if you want to compile that on the top line, you need to specify the version of the Solidity and tell the compiler this is a Solidity program. But inside this contract, we first declare a contract called coin, and then we have 2 state variables. One is called minter, it's of type address, and it's public. Then we also have a mapping from address to unsigned int. We declare it's private, called balances. So the minter will be the creator or the owner, the person who can administrate this whole coin token, and the balances stores whoever owns this token. Then we have an event sent, which will appear in the log of the EVM and the blockchain as got sent, and it has 3 parameters: address from, address to, and unsigned int amount. Recall that if we want to invoke an event, we use emit. Then first we have a constructor. This is when we are going to construct this coin contract. It is public, so constructor public is how we declare a constructor function. We only do one thing. We say minter is message.sender. So remember, message calls are general ways on how we operate on contracts, and message.sender is who actually sends this construction, who invokes this construction function. So he should be the administrator or the minter in this contract. Then we have a function mint, which means that the administrator can send out the monies initially, or he can just add value to a certain account. This mint will take 2 parameters: address receiver and unsigned int amount, means minting amount token into the account of receiver. We call it public. First, we require message.sender is minter, so only the minter can do that. Also, we require amount smaller than 10 to the 60, so we have like an upper bound to prevent any overflow. Then just call balance receiver plus amount. Function send is taking 2 parameters: 1 address receiver and unsigned int amount. Remember that there isn't a sender in the parameter, because the sender is going to be message.sender. The one who invokes this function is going to be the sender. This is analogous to the sender function when we are actually doing transactions on BNB or the native assets, because what we do is x.send or x.transfer. That means send to x instead of send from x. We are sending from the current account or current contract or current whatever. So the message.sender is going to be the sender. So first, we require amount is smaller than or equal to balance message.sender, meaning that he cannot send more than what he owns. Then we say balance message.sender minus amount and balance receiver plus amount. Then we emit an event called send, and we tell them that it's from message or sender, it's to receiver, and the amount is equal to the current amount. Finally, since we have declared our balances mapping to be private, we need a getter function in order to allow other people to know like the current balance of himself or some other accounts. So we have a function called balance of, which takes a single parameter address, is public view, and returns unsigned in balance. It just returns balance of token owner. Here we can declare it as view, because recall that view means you promise that you are not going to modify the states. So here it only reads from the current state and it's not making any change, thus we can declare it as view. So this is a very simple contract, and from this I hope that we can understand what generally should a contract be, and we also see that's not really hard, it's just some simple programs. Second is crowdfunding. First, let me briefly describe what the crowdfunding contract will be doing. So what is the objective of this contract, so we can better understand all of this. Crowdfunding should support two things. One is that, so first it will have a objective. It will have an expected money that it needs to raise. Then all the other person can pay and raise the money that is currently collecting. Then it also has a time limit. So if before the time limit the money it raised reaches the objective we set before, then the crowdfunding is successful and the author will be able to claim the benefits. However, if after the time limits we haven't reached the objective, then the crowdfunding fails and everybody will return their money. Of course, they need to pay extra gas fee, but they won't be able to claim their money back. Also, there's a small thing, is that we will be increasing the price of crowdfunding gradually. So you can see here at the very beginning it's 0.02 Ether, but then it will gradually update the price. So the later you participate in crowdfunding, the more you need to pay. Okay, so we can get into the contract now. We declare the contract called crowdfunding. We have address public called author, who should be the creator of this contract and who is also going to be the person who can collect the benefit after the crowdfunding finishes. We also have a mapping from address to unsigned int called join, which basically stores the people and the money that they have joined into the current contract. We have a constant called target, and we set it to 10 Ether. So this is our objective. Alternatively, we can pass in the target we want when creating this contract. This is analogous to the time. Right now the time is set to a fixed number, which is 30 days. Alternatively, we can make the constructor take two parameters. One is the target, one is the time, corresponding to the objective we want to raise and the time for this crowdfunding respectively. So we have an end time, we have a price, and we have a closed. So closed means whether the crowdfunding has finished. So first, the constructor, we just say author is message or sender, and then we say end time is now plus 30 days. That's a fixed period of time, which is 30 days, like a month time of crowdfunding. Then we have a simple function called update price. We declare it as internal because we don't want anybody to access it. Then we set rise is address this dot balance over 1 multiplied 0.002. So for every 1 Ether this balance currently raised, the price will go up by 0.002, and initially it's 0.02, so we update the price accordingly. Then it's a receive Ether function, which is the major objective for the crowdfunding contract. So recall that what we do with receive Ether function is that we do not have the function identifier, and we say receive and then external payable. first we require null is smaller than n time and it hasn't been closed. Otherwise, we say it's finished. So in require, the first part, this is going to be the condition. The second part is what will show up if the condition is not satisfied. So if this now is smaller than n time and is not being closed, then it's okay, we are able to proceed. Otherwise, we will show up, say it's finished. Second, we require joint message.sender is 0, so we don't allow somebody to participate several times. Then we require message.value is greater than the price. Otherwise, we say that's not enough payment. So notice what will happen is that if these require fails, we cannot proceed to here. EVM will invoke revert function. So all the payment will be reverted, so you don't lose your money. I mean, of course, you probably need to pay some gas, but you collect your main money. After we mark the value of the current sender to joint message.sender is message.value, we call update price. So we don't need to explicitly maintain the balance, because when we do update price, we do address this.balance, and this is automatically how much money we are currently maintaining in the contract. Then withdraw funding is when the author can claim the money. So the author can claim money as long as the balance, current money raised, has reached the target. So we do two checks. One is require message.sender is author. Also, we require address this.balance is greater than target. If that's the case, then we say okay, then we're done. The author is happy with whoever currently paid. We mark close to true, and we transfer all the money to message.sender or to author. Here again, message.sender.transfer means transfer to message.sender. Then we have a function withdraw. This is when the crowdfunding fails, all the participants will be able to claim their money. So that will be, first we require it has been finished. Also, we require that author has not claimed the money. Also, we require that we did not reach the objective. So the crowdfunding need to fail in order for you to get back your money. If it succeeds, then you cannot. You need to participate here. So if that is the case, all of these conditions is passed. We did not trigger not finished yet. We did not trigger money claim, author claimed money. We did not trigger target reached. Then we will be able to transfer money. So we send message.sender.transfer joined message.sender. So remember that joined of the address is the money that we stored, how much he have already participated and paid to the current contract. We just paid it back. So that is a crowdfunding, which is slightly more complex than the coin token, and demonstrate the usage of require mainly.